Hello. Yeah. So today to we are trying to find the general solution to a particular differential equation. So this is a differential equation 2x squared y prime prime plus xy prime minus 3y equal to 0. So we have been given the y of x, which is the particular solution, to be x exponent minus 1. So we should always note that my y1, which is equal to my y of x, which is equal to the x exponent minus 1, is the particular solution, which will be given in the question. So we can see clearly that this equation is homogeneous because the right hand side f of x, that's the right hand side. The right hand side f of x equals my right hand side f of x equals 0. So because my right hand side, which is the f of x, is equal to 0, we term the whole this equation to be a homogeneous. But then it is non-constant coefficient because the coefficient of y prime prime is 2x squared, that of y prime is x, that of y is minus 3. So it varies. It's not constant. It's not the case that you have only integers, say 2, 3, 4, but there is a constant which is 2 times another function x squared. So it makes this one non-constant homogeneous differential equation. So all that we are solving is non-constant homogeneous differential equation, where my particular solution has been given. So we try to write my differential equation to suit this equation. That's my y prime prime plus p of x y prime plus k of x y equals 0. So I'll make sure that the coefficient of my y prime prime is 1. So what will I do to make my coefficient of y prime prime to be 1? So unless I divide the whole of the equation by this 2x squared, the coefficient. So dividing the whole equation by 2x squared, we are getting y prime prime, because the 2x squared will cancel this, plus then x will go into 2x squared, 1 over 2x, y prime minus then 3 over 2 x squared y equals 0. So that this equation has been simplified in the form this, so we can compare the coefficients. Now I know my y prime prime is here, my y prime is here, so my p of x is 1 over 2x, whereas my k of x is minus 3 on 2 over x. But we are trying, or we are interested to find the integral factor mu, and to find the integral factor we always use the p of x. So we write the general solution or the answer. This is the shortcut for non-constant homogeneous, so non-constant coefficient, or homogeneous with non-constant coefficient. So we just keep this formula in mind. Just keep this formula. My y2 is always equal to my y1 multiplying the integral of e exponent, another integral of p of x dx, all over y1 square dx. Okay, so all that we are interested in that is that for non-constant homogeneous equation with non-constant, for homogeneous equation with non-constant coefficient, they will be given a y1. So this y1 will help you to find the another solution, which is y2. So just keep this formula, y2, to be always equal to the whole of this. So we try to solve the exponential part, that's the integral factor. So note there is a negative sign here. So I'll try finding my part, this part. I know that my P of x has always been given, or we find that my P of x was equal to 1 over 2x. So we make a substitution here where my P of x equals minus P of x equals 1 over 2x. But because here is negative, the negative sign will come. Then the P of x, which is 1 over 2x dx. Then after that, we try to simplify this. You know that my 1 over 2 is a constant, so it can come out. Then we integrate 1 over x. So we've not done anything to this. This is the same thing as this. Despite we have brought the 1 over minus 2 outside because it's a constant, multiplying 1 over x. Okay, so we integrate ln x. Sorry, we integrate 1 over x. I know that when we take the integral of 1 over x, we are going to get ln x. So my minus half ln x. So my e exponent ln x, then more or less it's like when we have a logarithm, like a logarithmic function like this. Let's say let's say 2 log x. Always we can write this one as log x exponent 2. So the constant or the one in front will come as an exponent. So that's what we are trying to do here. So this is ln. It's a natural log with a base e. So the e will cancel ln e. Then we try to make this constant come as a power of the x. So we are getting x exponent minus half from our laws of logarithm. So now I have the whole of this part to be x exponent minus half. So I make a substitution. So my y2, which is equal to, my y1 was given to be x exponent minus 1. Multiplying integral of, now the whole of this part, we had x exponent minus 1 over 2. So x exponent minus 1 over 2 all over the y1 squared. So my y12 was given as x exponent minus 1. Then I square it all dx. Okay, so we try to simplify. My y2 now becomes x exponent minus 1. Then we know that this is of the same base. So when we have a function of the same base dividing, we will add their exponent. More or less, this is x exponent minus 1 times 2. So we are getting x exponent minus 2. And because they are of the same base which they are dividing, you maintain one of the x values. Then we try to send the minus 2 up. So when it comes to be positive 2, then we add it to the minus half. You know that my x exponent minus half plus 2, we are going to get x exponent 3 over 2 dx. So we try to integrate this part, x exponent 3 over 2. And note that the x exponent minus 1 is multiplying the whole of this. So after integrating this, we multiply 2 by x exponent minus 1. So we know that when we integrate a function like this, we add 1 to the exponent, then we divide by the result. So that's what we are doing here. So when I add 1 to x exponent 3 over 2, when I add 1 to this, I am getting 5 on 2. Then you divide it by the answer, 5 on 2. But remember, because when you divide, we divide it by 5 on 2. So the 2 rather will come as the numerator, whilst the 5 will come as the denominator. So we are getting 2 over 5 x exponent 5 over 2 plus a certain constant c. Then after that, we try to multiply 2 by x exponent minus 1. So x exponent minus 1 times this 2 over 5 x exponent this, we are getting 2 over 5 x exponent 3 over 2, because x of the same base x x. So we try to add their exponents. So 5 over 2 plus minus 1, we are getting 3 over 2. Plus, then we multiply x exponent minus 1 by c. Then you are getting cx exponent minus 1. So we know that this 2 over 5 is a constant. So, and also we have another constant c. And you know that my particular solution was given, which was the y1. It was x exponent minus 1 from the question. So this part will take the one with the constant c1, which is c1 x exponent minus 1. Then the other side will take the one with the constant c2. Okay, so you know that 2 over 5 is a constant, so you can donate or represent 2 over 5 as c2, x exponent 3 over 2, x exponent 3 over 2. So this is my general solution. The whole of this is my general solution. y2 equals c1 x exponent minus 1 plus c2 x exponent 3 over 2. Okay, so if you've been asked to find only the solution for y2, then then my y2 will be the one which is attached to the c2, that's x exponent 3 over 2. So x exponent 3 on 2. Okay, so thank you very much. Please share, subscribe for more updates.